Hi AP kids, so today we are going to review correlation and scatterplots. So what you're given here is Jordan's data. Jordan is a friend of mine's daughter, and what we have for her is her age in months, so her age in months, along with how tall she is. So what we're going to do when we have lists like this is we're going to fill in list 1 and list 2 in our calculator by hitting stat and then enter. So fill in both your lists. And once you have that done, we'll be able to answer a series of questions. The first question that I'd like us to answer is, write the regression equation. So that means you need an equal to sign. And for us, we only deal with lines, so this is y equals ax plus b. So in your calculator, now that you have your list filled in, you hit stat, we go over to calc, and we go over to lin reg. My data is in list 1 and list 2, so I do L1, L2. I hit enter, and there we go. I have a line. Now, I don't like to use X's and Y's. Instead, I need to use the actual data that I have. So for this, we are recording her height versus her age. So I have height equals 63. So her height equals 0.639 times her age. And then the rest of that equation was plus 21.15. Now we put a hat over the height because we are predicting it. Now if your calculator did what mine did, which did not include the correlation coefficient, you can hit second 0, go down to diagnostics on, turn them on, just hit enter, and now when you do stat calc 4, you'll also get the correlation coefficient, and you can see that R equals 0.97. So if you're looking right here, 0.97 meaning strong positive relationship. So first question we're asked is, what does it predict when her age is 2.5? So I'm going to do her height. What's it predicted to be? 0.639 times 2.5, which means 30 months. So make sure you use the 30. Plus 21.15. Now using your calculator, all you're doing is plugging in here. And you should get 40.32, don't forget your units, inches. In reality, she was actually 37 inches tall. What is her residual? Residual, you need to know, is your error. For us, it's what actually happened minus what we predicted to happen. Well, she actually was 37 inches tall. We predicted her to be a little bit taller, so we're going to get a negative residual here. And when we do this, we get negative, and it's okay, 3.32 inches. She right now is 8 years and 4 months old, 100 months in all. What does your regression equation predict for her height? So similarly, we're plugging in now 100 into this equation. We get 0.639 times 100 plus 21.15. And plugging into your calculator, you should get 85.05. That's pretty tall. That's much taller than most NBA players. So part E then says, is this prediction in part D reasonable? No, absolutely not. This is over 7 feet tall, so it's not. And what we call this is extrapolation. The original data that we have on Jordan is really only her height up until she's 2 years old. Now she's 8.5 years old. It's way outside of our data set, so it's not reasonable to use that. And that's why this is not a good value. It's not a good prediction. So in reality now we're being told she's 4 feet 5 inches tall. So 4 feet 5 inches tall means there's 12 inches in each foot, so she would be 4 times 12 plus those 5 inches, which gives her 53 inches. So her residual now, because we're asked for her residual, would be the actual, her 53 inches, minus the 85.05. And we're going to get a humongous residual here showing us that this is not a good estimate, negative 32.05 inches. So that's really, really far off. Other things that you need to know on this topic are how to interpret the slope, the y-intercept, how to look at a residual plot for noise, and how to make a scatter plot. Those are things we will practice more in class. See you then.